Hi, welcome back to our Algebra 1 series. On this video, we're going to talk about our explicit and our recursive rules. Just remember that explicit means I can find any term without knowing the previous terms. I can find any term that I want at any time just by plugging in or substituting in a number for n and a number for r for my rate. If I have a recursive rule, then what I need is I need some number times the number that came before it, right? The rate times the number that came before it. So in this case, I would have to take the rate times the number that came before it. And I would need to know the first term. So our first term would be A1. First term's A1. I've got to know what the first term is. In this case, let's take a look at a few examples, then we'll take a look at some textbook problems. Here I've got my first term is -4. And this says to know any number, you have to know the number that came before it plus 3. This would be arithmetic. So this is saying for the second term, for any term, take the number before that and add 3. So I can take this number and add 3 and get -1. Or I can take that number and add 3 and get 2. Or I can take this number and add 3 and get 5. But I can't get any number until I know the first number. And we remember from earlier in this unit that if I were to graph this arithmetic sequence, because I'm adding the same thing every time, I'd get a straight line. On 2, same idea. I need to know the first term. Without this first term, I cannot do anything. But this recursively defined sequence says for any term, take -2 times the term before it. So if I have one term, I can take that term and multiply by -2. It's my rate, and get +4. And to get the next term, I have to take this term and I have to multiply by -2 to get -8. And to get the next term, again, multiply by -2 to get +16. And I can only get the next term if I know the term that came before it. And I can't start any of this process without knowing some starting point, some first term. So recursive rule. Again, what you need is A sub n equals the rate times this stuff right here just means the previous term. That's all this means. It's whatever term you just had. So I've got 2, 6, 10, 14. Right, what can I do? I can check what pattern I have. Well, is this geometric? No, it's arithmetic. I'm adding 4 every time. Okay, so I need an arithmetic formula. The arithmetic formula would be A sub n equals the common difference plus the previous term. So to find A sub n, I need to know that I'm adding 4 plus the previous term. So if I wanted to write a recursive rule, that's it. It's the previous term plus 4. On number 4, same idea. We got to find a pattern. Looks like I'm multiplying by 3 times 3 times 3. So to find any term, this is any term in general, any term. What I need to do is I need to take 3 and multiply it by the previous term. So if I wanted to find the next term, I would have to take -216 the previous term, the a sub n minus 1, and multiply by 3. So 3 times negative 216 would be negative 648. And I could keep going and keep finding these by multiplying 3 times the term that I just got. All right, let's try 5. Again, our geometric sequence is a sub n equals the rate times the previous term. So I need to figure out what the rate is. It looks like I'm dividing by 3. But what's another way to say dividing by 3? What's a fraction I could use? That rate would be 1/3. So to find any term, I have to take 1/3 times the previous term. Okay, now let's connect these ideas. We're going to write an explicit rule for the recursive rule. Here I've got a geometric. I can tell it's geometric because I'm multiplying. So this is a geometric sequence, which means I need, for an explicit rule, I would need a sub n equals and then I would need my first term times my rate to the n minus 1. So what do I need to know here? I need to know my first term and my rate. Okay, so a sub 1 in this case is 4. That was given. And my rate, what's my rate? It looks like in this formula, I can find rate times a sub n minus 1. Looks like my rate is 3. So all I have to do is substitute in a sub 1, where I see a sub 1, and rate where I see rate. So my final answer here would be a sub n equals my first term times my rate to the n minus 1 power. And that's it. You don't have to solve anything. We just need to write that rule. Let's try the same idea for an arithmetic sequence. How do I know that this is arithmetic? Well, I see the operation that's happening is -5. I'm subtracting something. And if I'm subtracting something, then I must know that it's arithmetic. All right, so here I've got my explicit rule for an arithmetic sequence is my first term plus my common difference times n minus 1. So what do I need to know? I need to know my first term and my common difference. All right, let's identify that. First term is 7, and my common difference from the other equation here is -5. So a sub 1 was -7, and my difference was -5. If I substitute those values in, I get a sub n equals my first term plus, and there are a couple ways you could do this. You could put plus -5 times n minus 1. That would work. You could also just put -7 minus 5 times n minus 1. That's also acceptable. Two different ways of writing the same thing. All right, now if we scroll down, it's asking us to write some sequences. I'm going to ask you to write a recursive rule here. Recursive rule for arithmetic would be a sub n equals the common difference plus the previous term. The geometric recursive sequence is the rate times the previous term. So this is geometric, this is arithmetic. I'm going to ask you to pause the video and try 13 and 14 on your own, and then unpause to check your work. All right, so the first one I should notice is arithmetic. It's plus 9. So I need the red function. I need to figure out what is my difference. It's plus 9. And the only thing that I can really substitute in here is that common difference. So a sub n would be equal to that common difference plus a sub n minus 1. And that's it. For this one, I'm multiplying by 3. That's what makes it geometric. So what I'd have to do there is substitute into my geometric equation. A sub n equals, the only thing I can substitute in is my rate times a sub n minus 1. All right, why don't you try 15 and 16? And then we'll come back, we'll check our work, we'll move on. All right, so hopefully you paused the video, tried these, and unpaused. On 15, I'm dividing by 3, which is the same as 1/3. So a sub n equals my rate times a sub n minus 1. I'm taking 1/3 of the previous term. That's all this means, 1/3 of the previous term. And for my next one, I'm adding 8. So a sub n would be positive 8 plus the previous term to get the next term. All right. Now, if you want to try a couple more, take a look at 8 and 9. Pause the video, try those two, and check your work by unpausing, and then we'll end the video. All right, this is kind of a challenge problem here. So this is 2n minus 3. If I think about what's happening here is I'm taking 2 times something minus 3, right? If I were to write out this sequence, let's say I start with n is 0. 0 minus 3 is negative 3. And then 1. Well, 2 times 1 is 2, minus 3 is negative 1. And then 2 times 2 is 4, minus 3 is 1. So if I keep plugging in numbers for n, this is the sequence that I would get. And what you notice is that you get an arithmetic sequence. Now, an arithmetic sequence is going to have the recursive rule a sub n equals common difference plus that previous term. And maybe now is a good place to stop, pause the video, and try it again. The only thing I need to know here is the common difference. And it looks like this common difference is plus 2. So positive 2 plus my previous term. On number 9, I have a geometric sequence, which you'll remember is a sub n equals my rate times the previous term. So I would pause the video again, make sure that we feel comfortable with that problem. Maybe try it again if you're not confident in your first answer. And then we'll check it again. Here it looks like my rate is 5. The base of this power is 5. So my sequence would be 5 times whatever that previous term is. And if I were to list out these terms, well, if I did first term, 5 to the 0 power, if I did 1 minus 1, 5 to the 0 would be 1, 2 times 1 is 2. For n equals 2, I end up with 5 to the second. Or sorry, 5 to the first. 2 minus 1. So 2 times 5 to the first is 2 times 5 is 10. Now if n equals 3, what I get is 2 times 5 to the 3 minus 1. 2 times 5 squared, or 2 times 25, is 50. And I could keep going, but it looks like I'm multiplying by 5. So my rate is 5. And then I could write that sequence that I did, a sub n equals 5, the rate, times a sub n minus 1. Or take the previous term, multiply by 5, and you'll get a sub n.